Okay, welcome back to Special Topics of Semiconductor Technology. In this section, we'll discuss a new concept of materials called bipolar transistor. Sometimes we'll call it bipolar junction transistor. So I'll say BJT, bipolar junction transistor. It's a combination of PNP semiconductor or NPN. That means you can have, for example, for NPN materials, you actually have two pair of PN junction with the P connect together to form a new type of transistor called NPN. So we call this bipolar junction transistor. It can be NPN type or PNP type with N semiconductor at the center. For a transistor, basically we call it a switch. So switch, it can be on or off. From binary system, it could be 1 or 0. So for binary system electronic device, basically it's composed of billions or millions of transistors. All those transistors can operate at an on and off state, representing the signal of 1 or 0. For this type of bipolar junction transistor, it can be used as an amplifier because of its mechanism. It can actually have a small input of so-called base current and large output of collector current, and this is also, we call this a gain, power gain, current gain, and it can be up to about 100 times. A small input of current and output a big current and drive your components. And we call this a amplifier. In general, it is using an analog circuit. It has a fast response. It can be used at high power device because the amplifier large current. Oh, sorry. Large current going through. So we call it a high power device. Okay. Sometimes we say power IC. This is so-called bipolar junction transistor. Okay, for NPN or PNP transistor, you came up with the different notations or symbol. Okay, for each of NPN transistor or PNP transistor, it has 3 lead. Okay, this is the so-called emitter. This is base, and this is collector. Okay, emitter, base, and collector. And the way to describe NPN or PNP in the electronic device symbol, it has a very similar symbol, but with arrowhead pointing out or into the emitter area. So this one emitter over here, this emitter over here. Okay, so and the arrowhead point to the N side. The N point to out, so the arrow point to outward, so this N, P, N type. And over here the arrow point to the center, so this P, M, P type. Okay, it's one of the simple way to distinguish what is PNP or NPN for the symbol, or maybe on an electronic circuit. This is a cross section of the NPN bipolar junction transistor. Basically, emitter, base, collector with the configuration like this. And you have over here on the notation N plus more large number of concentration for the N-type semiconductor materials. So you can introduce boron, phosphorus or arsenic in this area to converting the silicon substrate into N-type semiconductor area. And you can see over here is a P-type, but with very small area, thin area, and with the concentration only P, no plus sign. That means you have less concentration than N plus area. Thin area, lower concentration. Okay, and over here large concentration of N-type electron. And then coming through the dotted line over here, this is all N-type, N-type, coming back here, N-type. So this means from this area coming down to all the way up here, all representing the N-type area. So this is N, P, N, NPN bipolar junction transistors. The way the mechanism of the bipolar junction transistor operate, it's a complicated process. Okay, let's see if we can make it here. Make it. Basically, the structure similar to the one over here. You can see for the emitter, N plus. Okay, high concentration. For emitter, the P section, the base area is a thin area and low concentration. Okay, thin area and with low concentration. For the other N section, the collector, large area. Okay, and low concentration. You might put low concentration here. Actually, concentration here is not the thing we're worried about. Okay, so basically emitter, base, and collector has a geometry or dopant concentration different. Looks like here, emitter has a high concentration dopant. Base area is the thin and low concentration area. For another N collector area, large area, actually with low resistance. Low resistance, okay? The extra low resistance function basically come from this area, this so-called epitaxy. EPI, epitaxy silicon. Okay, epitaxy silicon. This epitaxy silicon is a special layer of silicon, single crystal silicon, grows on top of your substrate. Okay, on top of your substrate. This is called epitaxy, and it's n-type epitaxy area. To obtain a extremely low resistance area only by way of the epitaxy process. Okay, let's try to discuss in detail about how for example, NPN bipolar junction transistor is operate. Okay, NPN bipolar junction transistor. Alright, hopefully we can success in the drawing using this whiteboard. Alright, let's see here. This is emitter, this is base, this is collector area for N, P, N. Okay, remember when we say emitter, high concentration, for the base area, thin and low concentration. For the collector area, large area. Okay, and low resistance. Okay, that's basically the geometry and the dopant concentration point of view, like a difference between emitter, base, and collector. So let's see, for the emitter area, for n-type semiconductor, you have a lot of electron here. Okay, you have a lot of electron, high concentration. For the base, the p-type, thin and low concentration, so only have few holes in this area. And for the collector, the concentration is not the point that we are really worried about, but it has a large area with low resistance. Okay, and the connection to the power will be for the left-hand side PN junction over here. We need to have a forward bias. So let's see. For forward bias, N is connect to the negative, P connect to the positive, and this is forward bias. Let's see, we have a switch here. We could switch on and off. Alright? And for the left hand side, right hand side PN junction, then we are connecting to a reverse bias. So the P area will connect to the negative and connect to the positive. And here we'll try to put a motor here. Okay, this is the components. We try to turn on the motor. So for the operation of a bipolar junction transistor, let's look at the left hand side, the forward bias over here. Okay, over here is forward bias, and this is reverse bias. When it is a reverse bias, that means you don't expect the motor to turn on. Okay, so you are supposed to no current coming through the motor. The motor will not running at all. And what happened is, when you have a switch, you open a switch, turn on. This is forward bias, so there's a current coming through to the base. Because of the base with only low concentration, the base with only low concentration. So you came up with a current coming through the forward bias with a small current coming to the here with IB, the small IB at the forward bias part, okay, for the left hand side. But for the right hand side, because it's reverse bias, so you're supposed to have no current coming through at all. But look at here. When the forward bias part at the left hand side, when the electron move from the N-type area to the P-type area, large number of concentration. So a lot of electron diffuse to the right, toward the P-type area by diffusion, because a lot of concentration gradient here from the left high concentration electron to the right very low concentration of electron here. So a lot of electron movement coming through here. The emitter area emit a lot of primary charge particle. So over here, the primary charge particle. Primary charge particle is electron going through to the right, and it across the interface for the PN junction here. And all these electrons, once they move toward the right hand side, only a little bit of electron recombined with low concentration particle here, so it create only a small IB. Now most of the primary charge carrier coming from here across to the interface going to the collector side. So the primary electron diffuse to the right across to the interface to the base section, and most of the electron charge particle do not recombine with Hall and move toward the collector side. So a lot of electron coming from the p-type base area. Now let's look at the diode for the right hand side area. This area, a lot of electron coming from the Hall area. What is the primary charge carrier at the reverse bias area? For the p-type, okay, for the p-type, this will be Hall. So this electron is secondary electron. It is primary electron from the left hand side for n-type semiconductor, diffuse across the interface of base area toward the collector side. It becomes a secondary or minor charge particle at p-type semiconductor at the base area. And remember, as we mentioned, that even though you have primary charge carrier will contributing your current here, but at reverse bias area you have a very small current coming through at this area. At reverse bias, this is a primary charge carrier and this is secondary charge carrier. So the secondary charge carrier always move along the diode. So all these charge carrier coming from the right, all these charge carrier coming from the right, from primary charge carrier become secondary charge carrier here, and this secondary charge carrier will run through the negative bias. This is so-called reverse biased. A lot of electron did not recombine at the base area, and it will run through the collector side, so creating an IC current with very high current density. Oops, okay, we lost our drawing. So you know the concept. Again, a lot of electron here. All these electrons moving from primary charge particle to become secondary charge particle. Okay, it's MPN. From primary charge core becomes secondary charge core particle, where you can have a reverse bias here. And you have motor because of secondary charge particle were going through. So you a large IC collector current and a small current coming through IB. So that means the current gain equal to beta IC over IB. That can be somewhere around 100. So the current being amplified 100 times. So this is an amplifier. Okay, this is amplifier. This is the NPN bipolar junction transistor. Can be used an amplifier. Also, because of the switch you turn on and off, cause the motor here to on or off. So basically, it's also serve as a switch. On or off, 1 or 0. This is called transistor, bipolar junction transistor. So transistor basically is a switch. Okay, give you the signal of binary system on or off. Okay, by going back, so you can try to yourself to see if you can come up with a explanation of PNP operation of the bipolar junction transistor. If you can explain clearly, that means you understand the concept, the mechanism, how a PNP or NPN runs. Okay, so go ahead and try this. And this will conclude our today's talk about the bipolar junction transistors.